So we're going to continue with this chapter as discussed earlier with the default gateway. Now on every network, there has to be a device called a default gateway. Now a default gateway is typically a router or a layer 3 switch. Now a layer 3 switch is a type of switch that can do routing also as well as being a switch. So it's a switch as well as a router or a router. So a router can be a default gateway. And the features of a default gateway is that it must have an IP address on the same range as the rest of the local area network. It should be able to accept data from the local area network and is capable of forwarding traffic off the local area network. And it can also route to the other networks. So the default gateway is typically a router, that is a device that's going to be on a network similar to a switch, except that it will have two interfaces in most instances. One interface of the router is going to be connected to your local area network via the switch, and the other interface of the router connects to the internet. So the goal here with your router is that it is part of two networks at the same time. One part is to the internet, another part is to your network. So the part that connects to your network is called your default gateway. And as being part of your network, it will have an address similar to the addresses of the other devices on your network, so that it can communicate with devices on your network. So if you have a situation whereby you have no default gateway configured in your device, that is your PC won't be able to communicate outside your network. You'll only be able to communicate with the PCs within your own network. So how does the PC get a default gateway? Now, there are two main ways your PC will get a default gateway. The first method is you assigning the default gateway address statically into the settings of the PC. The other option is through something called a DHCP server. So most of the times when you connect to networks, our PCs automatically get IP addresses. Now they get that from DHCP servers. They'll get the IP address information as well as the default gateway information from DHCP server. When you're dealing with IP version 6, IP version 6 works slightly different from IP version 4. IP version 6 configured devices are able to discover each other. They will send themselves messages called the router solicitation messages. These messages help them discover the address of the default of their gateway as well as the other devices on the same network. So they'll automatically configure themselves, they'll automatically configure for themselves this information because router solicitation messages enable them to exchange information among themselves. So in that process, the router will inform them that it's a default gateway and they'll automatically add those settings in their network settings. That is IP version 6. So the messages they exchange are called router solicitation messages within IP version 4. So a default gateway can also be a static route to which it's a gateway of last resort. So as explained earlier, routers are responsible for sending traffic outside your network. But if they're going to send the data outside your network, they need to know where to send it. So sometimes a router may not know which network to send the data to. For that reason, they'll have a static route called a route of last resort. Now, this is a route that is put in the router that dictates and determines what a router should do in case it doesn't know where to send specific types of data. That is, it has received a packet and it doesn't know where to send the frame. So it doesn't know where to send the packet because when it looks at its routing table, it can't see a destination network. So it's normally a last resort route for any traffic or packets where the router doesn't know where to send them to. Now, for any device on local area network to communicate outside the network, they need to have a default gateway. Otherwise, their traffic will strictly be restricted to only and only a network, a device within their own network. So on your PC, on a PC, generally, every PC maintains a routing table to enable them to know where to send traffic if the traffic is going to be on the network or outside the network. So PCs maintain routing tables to help them determine what to do with specific traffic. So that routing table can be viewed from your command prompt. So I'll show you with mine. So on your command prompt, first of all, I'll share the screen. You need to know what IP address you have. Use the special command called ipconfig. So my IP address is 192.168.6.110. So this is my network. As you see, my default gateway is ending with .1. So it's an address on my cell network. See, the first three, the subnet mask helps us identify which parts belong to the network, which is these first 3255s. So 192.168 is the network, and the last address is the individual host on that network. So to know my routing table on my host, that is my laptop, I simply use the command netstart with an R. So here I simply will see my routing table for my IP version 4. So basically, if I'm sending any traffic to the 192.168.6 network here, all the traffic will be sent on link, not outside, but it will be sent to the same network card of my device, which you see here, which will have my IP, meaning that it will be sent on my same local area network. It won't be sent anywhere. So it's going to be sent to the switch, and it's going to look for that device that has the same network within my own network. So if traffic is going to go outside my network, we have a special route for that. 0.0.0 and 0.0 means that any network. So any destination on our routing table is identified by the 0.0 network. This means any. Okay. So if it's 192.168.6, it will go on the link. If it's any other network, it will be sent to the default gateway, because the default gateway is a router, and the idea here is to send it outside the network. So let me give an example of us tracing a route. So I could try to trace the route between my PC and the internet. I could trace a command trace route google.com. So as you see, google.com's IP is 172.127.170.206. So what will happen here is that my PC will look at its routing table and see, does this network match with my local network? The answer is no. As we saw in the previous example, it will send it directly to the default gateway, because this is not 192.168.6. And for that reason, you've seen that the first address it has sent it to is the default gateway. So all these are typically routers, and these routers are the devices through which the packet is being forwarded from one router to another until they get to the destination. So our destination is the IP of Google, which we have up here, which is the 172.127. So as you see here at the very bottom now, it has got a destination. So the data has moved from my PC through the default gateway, through all these routers, until it goes to destination. Why did it send it to this default gateway? Simply because if you look at the command netstart R stands for routing. This address of Google, the 172, does not match with 192.168.6. So it cannot be sent on the same network. It has to be sent via the default gateway. We'll continue. So that's a routing table for a PC. So, introduction to routing. So what we've just seen is pretty much with my trace route is a small preview of what happens with devices when they do routing. So here we have our PC1 trying to communicate with PC number 2. So the packet is going to be coming from our PC number 1. It's going to be encapsulated, as I showed in the previous video. It is packaged into a frame. The frame is going to be sent to the router number 1 on gigabit 0/0/0. Then 0/router number 1 on 0/0 will de-encapsulate the frame, and then de-encapsulate router number 1, sorry, is going to de-encapsulate the layer 2 Ethernet header, that is the frame. Remember, layer 2 is the data link layer, and the data type is the frame. And then once it de-encapsulates that, it's going to reveal the internal packet, that is point number 2, and then sees the destination address. Then it will compare that with the entries in the routing table, sees where to see it, re-encapsulates it, and sends to the next device, which is router number 2. What I've just shown to you when I run a trace route to google.com, basically what happened in the trace route I sent here, the trace route for google.com. Go back. Here, your PC sent a frame. It came to the default gateway. The gateway de-encapsulated the frame, so the information in the packet, so the destination, then encapsulated it again, sent to this device. This second device also de-encapsulates it, sees the destinations, re-encapsulates it, sends to the next device. So the devices are able to know who to send it to because they have to de-encapsulate the packet, see what is inside, and then know where to send it next. So all the devices keep doing the same thing until they get to the destination. Okay. So networking is based on packaging and packaging. Packaging, sending, unpackaging, seeing the contents, knowing where to send, packaging it again, and sending it. So it happens over and over again until a packet reaches the destination. So a router will have what they call routing tables. The routing tables determine where a packet is going to be sent. Routing tables help routers make decisions on where to send data. Now, there are a number of routes in a routing table. The first one is what they call a directly connected route. These routes are automatically added to the router, provided the interface is active and has an addressing. So these ones will be automatically created the moment you assign an interface an IP address. Then we have what they call the remote routes. These are normally routes that a router does not have a direct connection to, but they may be LANed. And they may be LANed in two main ways. An administrator may manually configure a static route and place it in the router's routing table, or a route may have been learned by what they call a routing protocol. Routers are able to learn about each other using routing protocols, or administrators can manually put the routes there. And lastly, we have what they call the default route. We also called it a gateway of last resort in the previous slide. This one will forward all traffic to a specific direction if there is no match for that route, that destination in the routing table. So a gateway of last resort normally will forward traffic out in a specific direction, especially if a routing table has no matching route. So this ensures that no packets are dropped and at least a specific direction in which a frame that is not matched can be sent. So what are the characteristics of a static route? This one is configured manually and has to be placed in by the administrator. And in case the topology changes, the administrator has to go and edit it. It is normally good for small and non-redundant networks and can also be used in conjunction with dynamic routing protocol or can be used as a default route. So these static routes are manually configured by the administrator. And whenever there's any change in a network, the administrator has to go and remove the route and modify it. Now we have what they call dynamic routes. Now these ones are learned automatically. So here we configure what they call a routing protocol. So two routers will have the same routing protocols and they will exchange information about the routes that each of them has. In case a route goes down, the router informs the other automatically about the route change instead of an administrator having to reconfigure them. So these ones, they do the routing updates, creation of routes automatically by learning from other routers. And these ones are normally very good because it's very easy to discover remote networks because routers keep learning from each other. And here, routers will always be very up to date. In case a route goes down, other routers update each other. And they will also help choose the best path to a destination because they update faster. So whenever there's a topology change, dynamic routing protocols are much better because they don't have to wait for an administrator to reconfigure them. They change immediately, so they're much faster. So dynamic routes can also share static routes and default routes with other routers. So if you have a dynamic routing protocol and you also have static routes, the dynamic routing protocol will inform the other routers about the static routes that you have. So they make it very easy for routing updates and routing information to be propagated. Examples of dynamic routing protocols are OSPF. OSPF can be configured on two routers and it will be able to exchange and share routing information. So show IP route is a command that can be used to share routing updates. So it will show you the routing table of a router, and I'm going to be showing you guys directly how this works with our packet tracer, and we'll be introduced to how routers actually work. So let me share my packet tracer. So now back to our packet tracer. So I'll quickly go to my packet tracer and I show you how we can have routing being implemented. So the first thing I want to do here is I am going to open up my packet tracer. So within my packet tracer, obviously, first thing is I need to have a router. So the router of choice is found in network devices under routers, and I will use an 1841 router over there, and then I'll get two switches because I want to demonstrate how routing actually works. Two 1841 switches. Okay, then I'll get 4 computers. So we then connect our PCs to the switches. So the type of cable we use is something called a copper straight through. I'll put this on port number 7. I'll put this on port number 8. Now you can use any port. You don't have to say that you have to use those ports. I've just used those ports randomly. You can choose whatever you want to use. So I place in this PC also on port number 7. My PC also I place on my port number 8 also. Now the network on this side is going to be the 192.168.2.0. So routers are there to link two networks together. So the network on this side for this PC is the 192.168.2.0 network, while the one on this side is going to be the 192.168.3.0 network. So it basically means that the devices on this end, let's quickly highlight them for you. The devices on this end are going to be one network, while the devices on this other end are going to be also another network. So I'll just have that like that and do it like that. So these are two different networks. Yeah, I've put them separate for separation purposes. So the goal here, a router is the only one that can link these two networks together. Even if you have to configure those IP addresses on different networks, with different networks from the switch, they will never be able to communicate together. So the router on one end, I'll use the fast Ethernet 0/0 and connect it to the switch on the right on fast Ethernet 1. Then I'll get the fast Ethernet 0/1, the remaining interface, and connect it to, I'll then get a cable, connect to fast Ethernet 0/1 and connect to fast Ethernet /1. So on this side, I've used fast Ethernet 0/0, and on this side, I've used fast Ethernet 0/1 on the router. I hope this is a bit straightforward. Now, let me begin configuring my PCs. So I begin with my PC number 0. Remember, it's on the 2 network. So I open up my PC. Then I'll assign it an IP address of 192.168.2.2. I'll begin from address 2. No gateway. I'll leave at that. Then I can configure the second PC. 192.168.2.3. Subnet mask is the same. It's fine. So now we get to this other network on this side. I say It's a 3 network, remember? I'll say 192.168.3.2. Then the last one, last PC, 192.168.2.3.3. So if I pass my cursor over them, you can see the IPs I've given. This is 3.3, this is 3.2, this is 2.3, and this is 2.2. So they all belong to the networks that I've specified there. So the next stage is us configuring the router. So I go to my router over here. I go to the CLI. So please remember, when you log into the routers, if it asks you to begin this initial configuration, always say no. So like all Cisco devices, I move from user exec to privileged with the command code enable. I go to the global configuration command using the command code configure terminal, and then I begin setting up the interfaces. So remember, fast Ethernet 0/0 belongs to the 2 network. So I say interface fast Ethernet 0/0, and I say IP address 192.168.2.1. Remember, we began giving out addresses from 2.2. Okay, then the subnet mask 55. So this interface by default has been shut down. So I have to issue a command called no shut down. So when I say no shutdown, I get a message called saying interface on the line protocol has changed state to up. And if I look at my packet tracer, I'll see that the connection between the router and this port has now turned green from red. So then I get back to the router and then I begin configuring the second one, the one that goes to the 3 network. So if you notice right now, I said fast Ethernet 0/0, meaning I'm still in the settings of fast Ethernet 0/0. So I have to exit out of them so that I begin going into the settings of the second interface. Fast Ethernet 0/1, which goes to the other switch on the left, okay, which is on the 3 network. So I say the IP address 192.168.3.1, subnet mask 255.255.255.0, and I also say no shutdown. So that will also activate the second interface. Okay, so now I have a situation whereby I've configured the router, I've configured the PCs. Now time to test if the PCs can communicate. So this PC here is 2.2. I want to see if it can communicate with 3.2. So I go to my command prompt and I open up the command prompt and I say ping 192.168.3.2. So I will not get a response. Why? Because I have not configured the default gateway. This PC is on a network. Let me config. This PC is on a network which is 192.168.2. But I'm here trying to ping a network ending with 3. There are 3 different networks. So as I explained earlier, because they're in the same network, this information has to be sent via a default gateway. So my error is because I lack a default gateway. So the solution here is I have to specify the default gateway. Now the default gateway is the IP address of the router that belongs to your network. So my default gateway is going to be 192.168.2.1. Okay, and that bit there is the IP address, and that there is the IP address of this interface here of the router that belongs to this network. So if you look at fast Ethernet 0/0, it has an IP address of 2.1, which is the same address as these other devices. So it means that all these devices have to have a default gateway of 192.168.2.1. This one also here has to have the same address of 192.168. 2.1. So all these others on this other network, remember, even them, this the interface that connects to their network is the 192.168. So it's the first Ethernet 0/1 with the 192.168 3.1. So all these devices also will need to have an address like 192.168.3.1, and then also the next PC also has to have an address of 192.168.3.1. So the gateway is always the same because all of them need that address to go out of their network. So if I run the same test again that I pinged earlier, that I got no feedback, I will now get replies to show that routing is actually occurring because the information that the data goes to the default gateway, and the default gateway sends the message out to the next network. So let me confirm and see if my information was saved. I go back here, I close this, I look at this 192.168.2.1, which is good. I close, and then the PC I'm trying to ping, I look at the address 192.168. This is a mistake, misconfigured gateway. I close that. So I go back and test the same PC and I see what happens. So I run the same command. 192.168.3.2 is now responding. I test the second PC with the same network 3.3. I ping, so I should get a response. So if I don't get a response, I have to check two places: the default gateway on my PC or the default gateway on their side. So how does this all work? So when I go to my router, I can run the simple command called show IP route. I run a simple command, say, called show IP route. So when I go to my router, I simply exit out of the interface configuration mode for this interface. Remember, config IF means I'm in the interface settings. So I have to go out of the interface settings of that first Ethernet. I exit out of global, and then I run a command called show IP interface. So show IP route, sorry. So now here I have the routing table. I can expand it for you guys here a bit. So if you look at the routing table, show IP route. Now it shows me that if the router sees any traffic with the destination of this network, it forwards it to first Ethernet 0/0. Okay. If the router sees any traffic with the destination of 3, it forwards it here. And that's how the exchange of traffic is done onto a network. Okay. So let me see if some of these commands are actually supported. I can close this here. If I go back to my PCs and I try to run a command, let's see if traceroute works here. Traceroute 192.168.3.1.2, sorry. So you see here it's the traceroute. The data comes, goes to the default gateway, and then is sent to the actual destination. So as long as the network is not belonging to the same network as the sender, it is sent via the default gateway. Okay, let me see. Start R. Okay, yes. So if I look at my net start R, right now my routing table, this is it in my packet tracer. It shows me that for any traffic that is unmatched, that is any network that's not my network, send the default gateway. Now the other traffic is sent onto the local network. Let's see if route print works. Okay, so it doesn't work. But so IP netstart R will always show you the routing table. So here the default gateway has been specified. All internal traffic is kept on the internal network. And that's all for this chapter.